All right, so today we're going to be looking at a couple of textbook examples. So if you want to go ahead and open up that file that you've got, that hopefully got saved. I found out a while ago that even though I have a downloaded copy of this, for some reason it seems to work better if you pull it up in a browser. So like if you right click on it in Moodle and tell it to open it in a new tab, for me anyway, for my instruction purposes, it seems to work better in a browser. Because when I pulled it up in Adobe, it wouldn't let me scroll, wouldn't let me do nothing. And I don't know why technology lately just seems to like it's out to get me. But Skynet, yeah, probably. Okay, so this is, which section was this? Yeah, okay, here we go. All right. So yeah, we're just going to look at a couple of textbook examples, and then before class lets out, we'll look at the lab itself. Lab itself isn't too bad. It's only got 10 questions on it, but all of you need some amount of work, whether it's just showing how you wrote it as a fraction, or using a formula, or whichever. All right. So the types of ones that you're going to see, we'll start with one like number 21. All right. So let's put 21 on the board. And now this is page, in the PDF, it's page 449. In the textbook, it's like, thank you, yeah. One of the early college students in my Tuesday, Thursday morning class figured out that this number is 27 pages above what it actually is. That means 27 pages of bibliographical hoopla at the beginning of this PDF. Hey, they have to have it for the lawyers. So, got to make sure it's in there. All right, so page 422. All right. Now, this is in the theoretical probability section, okay? So let's make sure that we know that. Theoretical. Kind of forgot how to spell that for a second. Theoretical probability. All right. So this is number 21. And it's asking, what is the theoretical probability of drawing a queen from a standard deck of cards? Let's throw the theoretical probability formula back up here. So it's the probability of event A, which in this case is the, drawing a queen out. Okay? The probability of event A, and that is equal to the number of ways A can occur over the total number of possible outcomes. Okay? So, whenever they say a standard deck, all they mean by a standard deck is one deck with no jokers. Some card games use multiple decks, right? And by, standard deck, they mean 52 in a deck. No jokers. 52 in a deck. All right? Now, out of that 52, how many queens are there? 4. Yeah, so there's 4 queens. Okay? Then 4 over 52 reduces down to what? 1/13. Now the textbook is happy with 1/13. Okay? But just for fun, go ahead and turn that into a percent for me. We'll do a little mini percent review. Can you turn a fraction into a percent? To use decimal as a bridge. divide 1 by 13. 7.69, so about 8%, right? Yeah, that's what I had in my head there. Good, yeah. So 1/13 or about 8% chance of drawing a queen. Okay, now again, theoretical. You know how many possible outcomes there are. You know how many times the thing you're looking for could happen. Did you actually draw a queen? Did you draw any cards? No. You just did the math. All right. Let's look at 22. All right. We'll do 22 next. So 22 says what's the theoretical probability of drawing a black card, meaning a club or a spade, from a standard deck of cards. All right, so now that we know the theoretical probability formula, and we're still in a standard deck of cards, so the total number of possible outcomes is still going to be 52. Okay, well, what are the colors of the cards in a standard deck of cards? Let me ask you this before you answer that. How many different colors are there in a standard deck of cards? 2. Black being one of them. What's the other one? Red. Now, so you could say that half the cards in a standard deck of cards are black and half the cards are red, right? What's half of 52? 26. Don't need a calculator for that one. So you got a 1 out of 2 or a 50% chance of drawing a black suited card, meaning whether it's a club or a spade. Okay. All right. That one's pretty easy. So let's look at, let's see, which one did we do at Andrews this morning? 25 is in your notes, okay? We could do 26 or 28. Y'all pick. Thank you. There we go. 26. All right. 28 at Andrews this morning. So 26. The theoretical probability that a randomly selected person has a birthday in June, July, or August. Randomly selected person has a birthday in June, July, or August. Okay? No. They don't. August does. June has 30. July has 31. All right, so in this instance, probability of event A, how many days in the year? How many days in the year? 365. Okay. Now, to figure out the number of ways that A can occur, you have to think, and Alex was kind of doing it out loud. We got 31 plus 31 plus 30. That's kind of the order he went in, thereabouts. So August, July, and June. All right? So before we can simplify, we have to figure up the top. So August and July, that's 62, plus June, 92. All right? Now, with your scientific calculators, will 92 over 365 reduce? One's even, one's odd. It's not to say that it's not going to reduce because of that, but it makes it more difficult. Will 92 over 365 reduce? There's a quick way to tell. So if you have this calculator, right, this calculator here, you do 92 ABC 365 and you hit enter, and if you get the same exact thing, not going to reduce. 92 365 is as far as it's going to go. So turn that into a percent for me? Just for fun. 92 divided by 365. 25%. Alex got 25%. Anybody else get thereabouts? Okay. Now, let me ask you this. On the surface, 92 out of 365, you know, to most folks, may not look like 25%, right? But check this out. If you cover up the 2 and the 5, you got 9 divided by 36. That's 1/4. So yeah, it's thereabouts. Plus, how many months in a year? How many did we account for? 3. 3 out of 12? 1/4. There you go. So many ways to do this, exemplifying why I hate probability. Because it's just, I don't know, it's too flexible. I don't like it. All right, so do we need any more examples on theoretical probability? I think we pretty much got it. That's pretty much the kind that you're going to see on your labs. I didn't put any on there like 24 and 23. 25 was in your notes. You know, so yeah. Okay, good. Let's scroll down on that page and let's look at some relative frequency probability. Okay. Now 29 is in your notes. It's in the notes that I gave you. Okay. So let's look at 30. Oh, who still needs to get this down, by the way? Anybody need a picture? Anybody still writing? Everybody good? Going once, going twice? Also, before y'all leave today, if you don't mind, would you remind me to hand out the wipes so you can wipe your station down? I've had a lot of people message me recently saying that they were out because they had strep throat, and I am not trying to bring that home because my daughter is very susceptible to strep throat. She has had it every winter for like the last 4 or 5 winters. So, yeah, hopefully not. Hopefully not. Fingers crossed. All right, relative frequency probability. Halfway through the season, a basketball player has hit 36 free throws in 50 attempts. Based on her performance to date, what is the relative frequency that her next free throw will be successful? All right, so the relative frequency, or why did I write theoretical again? No. Why did y'all let me write theoretical again? Like I had good sense. Relative frequency. Thanks a lot, guys. Now it looks like crap. Yeah, like it looks great every other time. But anyway, so number 30. Okay. So the formula for relative frequency probability is very similar to theoretical. It's just worded slightly different. So you know how theoretical, it talks in terms of, you know, what could happen, you know, or how many possible ways it could happen underneath how many ways you're looking for. In other words, you know, theoretical is what should happen. Relative frequency is what did happen. So like when we were talking about theoretical, when we were talking about drawing the cards, we were just talking about it, right? We were doing the math. You got this many cards, this many of this kind you're looking for, blah, blah, blah. Relative frequency is you actually drew the cards out. And every one you drew, you wrote down what it was. Or in this girl's case, she's actually shooting the basketball at the goal. So the formula, that's why it's written as number of times A did occur divided by the total number of observations. All right. So in this case, how many shots did she take on the goal? She took 50 shots at the goal. So that acts as the total number of observations. And then how many did she make? 36. Okay, so go ahead and see if that'll reduce. They're both even, so it should. Not 12. 18, yeah. 18 over 25. Very, very close. Much like her. All right, so when you make that into a percent, what percent is that? Is that 72%? All right, good deal. Yeah, so she's pretty good. She's a 72% ball shooter. So what the question was asking is, based on her performance, what is the relative frequency that her next one will be successful? Well, it's 72%, right? You take her existing data and you use it to make a prediction. So if she's at 72 right now, that's the chance that she's got to make in the next one. Easy peasy. All right, on the next page in the doc, let's clear that out. All right. So let's do 31, because 32 is kind of like, you know, playing the same song again. We already kind of looked at that one on Monday. All right, so let's do 31. All right, 31. You toss a coin 100 times. A coin, one coin. Okay. You toss a coin 100 times and get only 12 heads. Do you have reason to suspect the coin is unfair? So there's that pesky fairness test again. Okay, well, let's look at it this way. So the probability of event A, if we're flipping one coin, so let's do the theoretical first. All right, so let's just real quick do the theoretical one. Okay, so the probability of event A, well, if I'm going to flip it 100 times, okay, actually, no, wait. Sorry. That's not for that yet. If you're going to flip a coin, how many possible ways could it land? 2. If you're just looking for heads, that is one of the ways it could land, right? So that means that anytime you flip a coin, you should have a 50% chance of it landing on heads, right? Okay. That is, of course, assuming it is a fair coin. Now, if we're going to do the relative frequency of this, relative frequency uses the actual data. So you actually went and tossed it 100 times. That's where that 100 goes. Sorry, I was jumping the gun. That's where the 100 goes. How many heads did you get? 12. Okay. Well, that's 12%. Is that anywhere close to what you were supposed to get? No. So can you say that there was some tomfoolery with this coin? Yeah. Because it's not close enough to 50, so you could say that it's unfair. It's probably the coin they use in Madden. If you know anything about playing Madden, whenever you're doing the coin flip, you always pick tails. Always. Yeah. So this one landed on tails 88 times. Yeah, it's the Madden coin. All right. So again, relative frequency probability, you actually have collected data. All right. You either flipped the coin, you drew the cards, you shot the basketball, threw the football, threw the baseball, did a survey, took a poll, took a vote, something to actually say, okay, here's this, here's that, here's this, here's that, here's option A, option B, whatever. All right? Everybody good on relative frequency? Okay. Now, let's look at the questions 33 and 34. All right, so we're on 33 and 34 right here. There's really nothing to figure for these two. I just want to look at them for a minute. The question is asking which type of probability is it? So is it theoretical or relative frequency? So now, like we've seen some more examples, we know what a theoretical problem looks like. We know what a relative frequency problem looks like, right? So 33, what is the probability of being dealt a pair of aces in a 5-card hand? What kind of probability is that? Theoretical, right? You know the number of outcomes, you know what you're looking for, theoretical. 34, what is the probability of being injured in an automobile accident next year? They unfortunately have collected data for that. So if they have collected data, relative frequency. Yeah. That's how they come up with saying, you know, you're more likely to get in a car accident than get bit by a shark or struck by lightning. I was like, well, yeah, but need the car. Don't need the shark. Trampled by a cow. That wouldn't be good. All right, 35 through 38. It's not occurring is the third part of your lab. All right, events not occurring. 35, I think, is already in your notes that I gave you. So let's do 37 and 38. All right, 37 and 38. Everybody got these two? Anybody need to get a picture or whatever? Oh, great. All right. Hope green shows up on the recording. This is, what page is this now? 423, I think. Well, we'll say it is. So odds, or not odds. We're not covering odds. Event not occurring. Okay, so 37 says, what is the probability that a 75% free throw shooter will miss his next free throw? I get it. This one's easy. But let's just, you know, if you had this one on your lab and my instructions said, you know, there is still something that you need to show, well, then show how you put it into the event not occurring formula. Okay? So the probability of not A is, let's see, what did it say? Probability the free throw shooter will miss his next free throw. So not make the shot. Okay? The mainstay of the event not occurring formula is that in order to find the probability of it not occurring, you have to know one very important piece of information, the probability of it occurring, right? So before you can find P of not A, you've got to find P of A. They gave it to us, didn't they? Yeah, it was really nice of them this time. 75%. Okay, now if you need it to for the subtraction part of the formula, you could make that 0.75, or you could make it 3/4. Probability likes fractions and percentages. Decimals, but fractions and percentages they like. Okay, so now that we know this, because we have to have that for the formula, right? Because the formula says that the probability of not getting event A is 1 minus the probability of A, right? So We got 1 minus 3/4. If you used 0.75, it'll still work out just fine. So 1 minus 3/4 is 1/4, or 25% of missing it. Now, like I said, I get it. Didn't need to take this one that far. This one was pretty easy, right? We've been, folks have worked with 75% for years. They pretty much know everything about it. But I used it to show you where everything went in the formula. Okay? All right, so wrap that one up, and let's do 38. Okay, 38. What is the probability that the next person you meet was not born in July? I just kind of got this funny picture of Alex going up to people outside in the parking lot, like, you born in July? You born in July? You born in July? Get that finger out of my face. Yeah, so it says assume 365 days in a year. So the probability of not A, created a monster. The probability of not A, and I only said Alex because he had this look in his eye like he was going to go do that after class. Like he was going to go in the parking lot and start, yeah, just start bugging people about their birthday. All right, so the probability of not A is not born in July. That's the event you're looking for. Yep, that's the very next thing that I'm going to put on the board. We have to find the probability of being born in July so that you can get the probability of not being born in July. So this goes back to the problem in the notes about being, finding someone who's got a birthday in January. All right, so the probability of being born in July comes out of 365 days. All right, how many days are in July? 31. 31. June has 30, yeah. All right, 31 out of 365 is not going to reduce. 31 is prime, and it's not a factor of 365. At least I don't think it is. So now you go back to your event not occurring formula. Okay. So again, the probability of A, the probability of not being born in July, that is 1 minus 31 out of 365. Now, let's see who remembers elementary and middle school whole number and fraction conversions. When you're subtracting a fraction from 1, what do you turn that 1 into so that you can subtract this by hand? It's probably been several years. I have a 10-year-old, so this is, at the front of my brain. Right? You take the 1 and you make it 365. Okay, now if you didn't want to do that, because I've been working at Tri-County like 6 or 7 years, I've come across a lot of people that are allergic to fractions. So if you want, if you want to make it a decimal, go ahead. It's not going to hurt a thing. Oh, the probability of not being born in July is 334 out of 365, which is a pretty high percentage if you made it 1. Let's go ahead and do that. I did, yeah, 334. So what percent is that? 334 out of 365. 92. Yeah, it should be pretty high. Yeah. So 92% chance that somebody is not going to be born in July because you're accounting for the other 11 of the 12 months, right? Yeah. Okay. Any questions on how to figure out an event not occurring? Now we're going to look at it here right now, but there are a couple on the lab where you have to actually figure up your total number of outcomes in a couple of places. It's not just going to tell you. We've had a bunch where it said, oh, well, it's 365 or it's 52 or stuff like that. No, because you're going to be dealing with some other types of questions and you have to figure out what the total is. What? Yeah, they're taking it easy on you. Okay, so let's go. I'm not even in the right section. There we go. So go to, I've got a lot of videos in here for y'all if you need them. Go where it says Probability and Statistics Lab 2, student copy. No, I don't have it to open the right way. Should have, but I didn't. Okay. All right. So let's look at what you're going to be dealing with. Okay. 1 through 4. Oh, let me do this for the recording, because I think we're done with the whiteboard. All right. Yeah. So 1 through 4, you're just finding the probability. They're just run-of-the-mill probability problems. So number 1, on a multiple choice test, each question has 6 possible answers. If you make a random guess on the first question, what's the probability that you are correct? Now, I had a student out at Andrews this morning that asked, how do you show work for that? You set up the fraction. Easy peasy. Okay? That's all you got to do. And with these first 4, that's usually all you have to do. Number 2, a die with 6 sides is rolled. What's the probability of rolling a number less than 5? Again, another student out there this morning asked, does less than 5 include 5? And if you're getting into a technical term, you're getting into inequalities. Less than 5 is everything below 5 but not including 5. Less than or equal to includes 5. But less than 5 does not. So 5 is not included in that. Good question. Number 3, a bag contains 6 red marbles, 3 blue marbles, and 7 green marbles. If a marble is randomly selected from the bag, what is the probability that it is blue? Okay. Now, these types of problems, I've had people miss them because they look at, oh, there's 3 in there, and I'm only picking 1 marble. Is that all you have to do with this? No. You need to get the total number of marbles in the bag and then put how many blue there could be, how many blue ones there are in there, and then reduce it down if it'll reduce. Okay? Number 4, 2 6-sided dice are rolled. What is the probability that the sum of the 2 numbers on the dice will be 4? This is like that problem we saw on Monday where that person had 2 coins and they were flipping them 100 times. And they had to list how many possible outcomes they could have. Because they had 4 possible outcomes, right? Well, they had 4, but they really had 3. Because they had 1 where you got no head, 2 where it could have been 1 head, whether it's the first one or the second one, and then 1 where you got 0 heads. So with this one, you need to list out the pairs on the dice that could add up to a 4. Okay? There's not going to be. And so then, after that, you got to think, okay, then how many total numbers are there on 2 dice? Number 5, 6, and 7, you're doing relative frequency. I just went ahead and told you. Okay? Relative frequency deals with, again, collected data. All right, so you could say 1 through 4 dealt with theoretical. All right, of 1,801 people who came into a blood bank to give blood, 212 had high blood pressure. Estimate the probability that the next person who comes in will have high blood pressure. So that one's pretty simple. Number 6, you count 61 heads when you toss a coin 100 times. If you don't know whether the coin is fair, what is the probability that the next toss will be heads? All right, so just set that one up, and you're good. Just make sure that your decimal's in the right place on all 3 of these, because all 3 of these, the answers are in decimal form. Number 7, in a poll, respondents were asked whether they were planning to vote in the local election. 481 respondents indicated that they were, and 421 said they weren't. What is the probability that the next respondent questioned will indicate they're planning to vote? In the spring and in the summer, when people miss this, it's because they just did 421 divided by 481. That is not correct, because 481 is not the total number of observations. You've got to put those together. Okay? 8, 9, and 10. Events not occurring. All right? A bag contains 5 red, 4 blue, and 1 green marble. What's the probability that the marble you choose is not blue? Okay, again, what's the key part of events not occurring? You've got to find the probability first. Okay? 9, you're dealt 1 card from a 52 card deck. Find the probability that you are not dealt a 6. Okay? And then what is the probability of not rolling a number larger than 4 on a fair die? Okay? The probability of the events not occurring are going to be the trickiest just because of how they're worded. All right? Now, one more thing that I want to make sure that I get on the recording before I close this out. Okay? This past, or I guess yesterday, when the statistics lab was due, I had several folks send me a message that said I couldn't get my file to upload. And that's not the first time that that's happened. I mean, it's across, it's not just here, or it's not just in one class, it's across all my classes. So I need to show you something, okay? I sent an announcement out about this earlier, but just in case you haven't read it yet, let me show you something, all right? So on these work entries, when I set them up, there is a limit to the size of the file that you can attach. Okay? It's only 50 megabytes. It's not a lot. So in that announcement I sent out, I said, if it won't attach, a couple things might have happened. One, if you've just got one picture and it won't attach, probably too big. Or maybe it's in a, wrong kind of file type. I don't have any limits on file types in here, so that shouldn't be doing it either. And, it's not because you're uploading too many files, because I've got it set to 20. All right? If it's not attaching, you've exceeded the size. Whether it's with one really big picture, or like say if you've got a bunch of little ones, let's say you're uploading 3 pictures. Okay? The first 2 that you uploaded put you at like 47 megabytes. That third one's going to put you over 50. It's not going to let you attach it. All right? And again, this is online, folks, too. But yeah, so if it won't attach, or if it won't upload, that's one reason. It's too big. Okay? Another reason could be your internet speed, which I know that a lot of us have no control over. I fully understand that. But it is what it is. If your internet's too slow, sometimes when you try to upload this stuff, or submit it if it's an answer entry, if it just sits there and spins for too long, it'll eventually time out. And it'll say can't upload, because your speed is not strong enough to do that. So unfortunately, what you're going to have if you need to find 2. Let's see, there was another one. Let's see, what else did I say? I have this bad habit of not being able to remember everything I tell y'all. I blame the concussions that I had playing high school football. All right. Oh, yeah. And then sometimes Moodle's just a jerk, like it's being right now. Okay, let's see, what else did I put on here? Yeah, one way to fix it if it's too large, and I don't try to encourage people to do this, and I'll tell you why. But if you've got a lot of pictures and it's too much and it won't attach, try putting them into a Word doc. Now again, the bad thing about that is that once you've got it in a Word doc and you upload it, if you put a Word doc into Moodle, for some reason when I pull it up to grade it, it only pulls up the first page. And I don't know why, and I don't know how to fix it, even if you can fix it. But I'll just open up the actual file and look at it then. So putting it in a Word doc should shrink it down somewhat. If it's a Chromebook, okay, for some reason, when Moodle applied that summer update, that update said death to Chromebooks in its code, all right? Chromebooks are having an absolute fit with Moodle. I've had several CCP students, because you know they've all got their Chromebooks, message me and say, hey, I can't get it to upload, hey, can't get it to upload. And it turns out they're on a Chromebook. And I really don't know what the deal is. Some do and some don't. Yeah, like I said, some do and some don't. I had to borrow a Chromebook at Andrews High School this morning because the internet wasn't letting me on it. And that was assigned to a staff member was like, you know, it just wouldn't go. So if you are on a Chromebook or a MacBook that is not letting you upload things, you might need to try, and I put this in here on purpose because I'm a dinosaur. You might want to try getting on an actual computer. Works a little better. And then lastly, you know, we talked about the internet issues. Again, I know that not everybody's going to be able to fix that. And I didn't put this in writing on here, but I've said before, you know, if you have if you live somewhere out that's pretty far out, like pretty remote, and you have to rely on something like SkyTech or Frontier, it might work, it might not. I don't know. So your best bet is to go somewhere that's a little bit quicker. Public library, go to the library here, go to the center. If you need to use the lab, you know, to work in here, that's fine. You know, but just remember, a lot of people use this lab. Like we had some folks taking a test today. So as such, take one. One of those should clean your mouse, keyboard, table, and your seat back. All right, make sure you grab your seat, especially look here. You see where my hand is? See where my hand is? Get that. All right, make sure that you get that, and you can get that when you leave. Last thing to remember, again, any class you're taking that you're looking at your grade and you're kind of like, this ain't really working out. November 9th, last day to take yourself out of a class. Okay? I've got some online folks that really need to be considering this. This is, you know, and I got some in-person folks need to be considering this too if we're just, you know, shooting straight with everybody. So, you know, again, November 9th is the last day to take yourself out of any class and not have it count against you. Because if I do it, I can do it at any time. And if I do it, it's a big old fat 0. Okay? All right. Finish cleaning off your station, and then when you got it, you're free to go.